Good morning to everyone. Students, so today we see the definition of congruence in number theory and let us discuss problems on congruence. So first we see the definition of congruence. Let m be a positive integer and let a be any integer. Then we can say that a is congruent to b modulo m if m divides a minus b. So m divides a minus b. So this is a condition. So then we can write the congruence form a congruence b modulo. That means a is divisible by m. Then the remainder is b. For example, 23 congruence 3 modulo 5. So that means 23 can be divided by 5. Then the remainder is 3. So that's a definition of congruence. So that's congruence is a different form of the remainder. The remainder should be written as different form of the congruence types. So that is a form A congruence, B modular. So next we can see the properties of congruence. So congruence first property, the congruence is the equivalence relations. So equivalence relations that means that have the three axioms: reflexive, symmetric, transitive. So reflexive means A congruence, A mod. So that is M divides A minus E. So reflexive seems same number reflect to the same number and modulo. And symmetric means A congruence B mod M. So that means M divides A minus B. So it will be written as M divides minus of B minus A. Minus should be take common. Also, the divisible by M minus of B minus A, it automatically is positive. So M divides B minus A. It's also divisible, exists. So far, you can write B congruence A order. So it will be satisfied with symmetric axioms. So next transitive, A congruence B model and C congruence, B congruence C. So I want to show that A congruence, I want to show that A congruence C mod. So A congruence B model means M divides B minus A. And B congruence C model that means M divides B minus C. So this two divisibility should be combined itself. M divides B minus A minus B plus C. You can subtract the divided B minus A and B minus A and BB should be cancelled. So then it will be get M divides C minus A. So automatically it will be satisfying this transitive axioms, which implies A congruence C model. So this three axioms satisfy, so the congruence is a equivalence relations. So next property, let A congruence B model and C congruence B model. Then addition, additive property, A plus C congruence B plus B model. And product AC congruence BD model. And then next third one, we can increase the sum powers or greater than 0. So A power R congruence B power R mononomial. Okay, so additions, multiplications, and increase the sum powers, positive powers, A power R congruence B power R under mononomial. And bad axioms, A congruence B model if and only if A equal to B plus Kn. So some integer K. So the congruence types, it will be written as equation forms. So A congruous B model, which implies if and only if also congruous to each other. So A equal to B plus K. So next, we'll see the problems on congruence. Problem. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial plus and so on plus 100 factorial is divided by 50. So this 15 like this written as 3 into 4. So the given numbers factorial form 1 factorial plus 2 factorial plus 3 factorial plus and so on 100 factorial. I want to find the remainder. This 100 factorial sums is divided by 15. So the divisor is 15 should be written as 3 into 5. This 3 into 5 should be occurred in 5 factorial. So 5 factorial can be written as 1 into 2 into 3 into 4 into 5. So from 5 factorial onwards, it can be divisible by 15 because 3 into 5 should be cancelled. The remainder should be 0. So from 5 factorial onwards, the reminders are 0 and modulo 15. Also 6 factorial, congruence 0 mod 15. And so on. 100 factorial, congruence 0 mod 15. Because each factorial, it contains 3 into 4. So automatically it's divisible by 15. Then we get the remainder 0. So now I find the remainder from 1 factorial to 4 factorial. 1 factorial to 4 factorial. We need to obtain the remainder from this 4 terms. Then finally we get the remainder, equivalent remainder. So therefore 1 factorial, 2 factorial plus 3 factorial plus and so on. Also 4 factorial plus 5 factorial plus and so on plus 100 factorial congruence. 1 factorial, we can explain this 1. 2 factorial is 2. 3 factorial 6. 4 factorial 24. And 5 factorial, we get the remainder 0. From 5 factorial onwards to from 100 factorial, we get the remainder 0 under modulo 15. So now adding this numbers 24, 30, 32, 33. Modulo 15. So now 33 can be divided by 15. 2 5s are 30. So remainder is 3. So 3 modulo 15. So therefore the required remainder is 3. Okay. Go to the next problem. Compute the remainder when 3 power 247 is divided by 24. So now we found the remainder when 3 power 247 is divided by 25. So now that for any power should be given the problem. So the power's value can be expressed as binary operation. So 2 power 47 can be expressed as binary operation. So 2, so 1 times, 2 times, 3 times, so it will done 1. And again by 2, 1 times 1. Again 2, 31 into 15, 0, 2, 7 times 1, so 6, 1, 2, 1 times 2. So 1, so this 2 power 47. 47, 1, 1, 1, 0, 1, 1. So this binary operations can take the powers of 2. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 1 what we see, 2 power 6, 2 power 7. So the 2 power 7 means, so 2 power 0 is 1, 2 power 2 is 1, so 2, and 2 power 2 is 4, and 2 power 3 is 0. So we can omit this, and 2 power 4, 16, and 2 power 25 is 32. Next, 2 power 6 is 64, plus 2 power 7 is 128. So now we can apply the base 3 power 247. So the 3 power 247 can be expressed as a binary operation sums. 128, 64 plus 32 plus 16 plus 4 plus 2 plus 1. So now 3 power 128, 3 power 64, 3 power 32, 3 power 16, 3 power 4, 3 power 2, 3 power 1. And then modulo 25. So now I find out the remainder from which are the powers. So take this equation 1. So now finding the powers. So first 3 congruence, 3 modulo 25. So now squaring the successfully, then we get the reminders. So now power 2 on both sides. So 3 power 2 congruence, 3 power 2 modulo 25. So that will become 9 modulo 25. So again, increase the power 3 power 4 congruence 9 square modulo 25. 9 square means 81. So 81 can be divisible by 25. Then we get the remainder 6. So 6 modulo 25. Again, increase the power. So 3 power 8. So 6 square modulo 25. So 6 square means 36. So 36 can be divisible by 25 to get the remainder 11. Modulo 25. Now again increase the power 3 power 16. Congruence 11 square. 11 square means 120. So 121 can be divisible by 25. We get the remainder 21 modulo 25. So again increase the power 3 power 32. Congruence 21 square. So 21 square means 441. 441 can be divisible by 25. We get the remainder 16 modulo 24. So again increase the power. So 3 power 64 congruence. So 16 square 256 modulo 25. So 16 square means 256. So 256 can be divisible by 25. We get the remainder 6 modulo 25. So finally, one more increase the power. So 3 power 128 congruence 6 square congruence modulo 25. So 6 square is 36. So 36 is can divisible by 25. So modulo 25. From all those power, we are getting the remainder successfully. So all the reminders should be substituted here. Congruence. So 3 power 128 means 11 into 3 power 64, the remainder respective remainder 6. 3 power 32, the respective remainder 16. And 3 power 32, the respective remainder is 21. And 3 power 4, the respective remainder is 6. And 3 power 2 is 9. 3 modulo 25. So now, so product of this 6 and 16. So we're getting 96. So 96 can be divisible by 25. Uh, Also, sometimes we can express as negative remainder rounds. So it will be have getting 96. Product of 6 and 16 is 96. So 96 can be divisible by 25. We get the remainder, negative remainder minus 4. And 21 is not divisible by 25, but it can be expressed as negative remainder minus 4. And 6 and 9. 9 6 are 54. The remainder positive 4 into 3 modulo 25. So 11. So from product of this, so 4 4s are 16 plus 16, 16 4s are 64. The remainder 14 into 3 modulo 50, modulo 25. Congruence, and from which 11 and 14 product this 11 and 14 product itself, we get 154. 154 can be divisible by 25. We get the remainder is 4 into 3 modulo 25. So finally 4 into 3, 12. So finally we get the remainder is 2. So the required remainder is 2. So now three types of congruence should be solved. The first one is linear. 1. The second one is system of linear components. And that one is 2 plus 2 systems. So now we can see this solving linear congruence and system of linear congruence. So linear congruence means the linear congruence is of the form AX congruence B model. So it will be how it has a unique solutions. It has a unique solution if if A comma M, GCD of A comma M is 1. GCD of A comma M is 1. So it will be get GCD is 1, then we can able to find the solution. So the solution is x equal to x naught plus m by d into t. That t is any integer. For t is belongs to any integer. So this is a solving for system linear congruence. So the linear congruence is of the form Ax congruence B mod. It has a unique solutions if A comma M, GCD of A comma M is 1. See, if this GCD of A comma M is 1, then we can able to find the solution. The solution is of the form x equal to x naught plus m by d into t. The x naught should be obtained by some particular values. It is obtained by some arbitrary value. We can choose this and solving this congruence equations, we can selecting the x naught values. So for example, 3x congruence 7 modulo 13. So A is 3, B is 7, and M is 31. So now check the conditions. GCD of A comma M. So GCD of 3 comma 31 is 1. So therefore, the given linear congruence has a unique solution. So therefore, find the x naught. So first find x naught value. So this x naught value we can choose by trial. So we can choose this x value product with the 3. Then total product, it can be divisible by 31. We get the remainder 7. If we are getting 7, then corresponding x is that's a particular solutions. So now take the x naught is, let me take x naught is 5. Randomly you can take 5. So 3 5s are 15. So 15 is not divisible by 31 because 31 is the less value. 15 is the less value of 31. So next we can take 10. So 3 tens are 30. So 30 is not divisible by 31. Okay. Next we can take 11. 3 11s are 33. So 33 can be divisible by 31. We get the remainder 2. But I want to get remainder is 7. I want to get remainder is 7. So don't need to take 11. So next choice 12. So 3 12s are 36. So 36 can be divisible by 31. We get the remainder is 5. So successfully is going on. We can choose x naught is uh, 21. 21, 20, let us take 20. 3 20s are 60. So 60 can be, so 15. So let us take 15. So let us take 15. So 3 into, so 3 into 15, 45. So 45 can be divisible by 31. 31, we get, we get 40. So it is not sum. So next we choose 20, 3 into 20, 60, modulo 31. So 60 can be divisible by 31, we get 1. Okay. So 90, 3 into 90, 57. So 57 can be divisible by 31. So not get sum. Okay, above, we move to above 20. So 3 into 21, 3 into 21, 63. It's not possible. And 3 into 22, 66. Okay, 3 into 23, 69 can be divisible by 31. 2 31 so 69 can divisible by 31. 2, so 7. We get the remainder 7. So therefore, the 23 is a particular solution. X not equal to 7. So this x naught value substitute in the solution. So therefore the solution is, final solution is x equal to 7 plus and 31 divided by, and GCD is 1. D is called GCD. So 1 into T. So final answer is 7 plus 31 into T. So T is for any integer. So the trial solutions we can find out substitute, the linear congruence should be balanced. Then corresponding x is called particular solutions. So that will be take x naught. So this x naught value substitute with the formula. We get the general solution of linear congruences. Okay. So now we can move to system of linear congruence. So go to the next topic. We can solving the system of linear congruences. So system of linear congruences means x congruence A1 mod M1, x congruence A2 mod M2, x congruence AK mod MK. So this is called the system of linear congruences. So this is the system of linear congruences solved by Chinese remainder theorem. The Chinese remainder theorem is used to solving the congruence equations with one variable and different modulo which are relatively primes. I shown this statement. So the linear system of congruences x congruence A1 mod M1, x congruence A2 mod M2, etc. x congruence AK mod MK, where M1, M2, etc. MK are pairwise relatively prime. So for any two pair, it has to be relatively prime. That is GCD is 1. So then the system of congruence has a unique solution modulo M1 into M2 into etc. So now I proving the statement. Also, the Chinese remainder theorem states that the above equations unique under the modulus product of M1, M2, etc. Mk. So the proof consisting of two parts. So the first one is existence part, the another one uniqueness. So existent parts, let me consider n equal to m1 into m2, etc. Mk, and n1 equal to n by m1, n2 equal to n by m2, etc. Nk divided by n by Nk. Since M1, M2, etc., Mk are pairwise relative neutral. So that is the GCD of Ni, Mi congruence law for I equal to 1 to K. So first we construct the solution to the linear systems. So the congruence Ni, Yi congruence 1 mod Mi for I equal to 1 to K as a unique solutions. So let us consider x equal to congruence, x equal to A1, N1, Y1, A2, N2, Y2 plus AK, etc. plus AK, NK, YK. So next, so this X is a solution, the system of points. I want to proving this X system of solution of system of congruences. So since Ni congruence 0 mod Mk for I not equal to n. All the terms except kth terms. So it's all the terms except kth term, kth congruence. That means kth congruence. One congruent 0 mod Mk. So since Nk Yk congruence 1 mod Mk. So we see that X congruence AK, NK, YK, which implies AK mod NK. So thus, that means X satisfy the equations. So the corresponding YK value, it will be satisfied in any one of the kth components, corresponding kth components. So thus, X satisfy the every components. Every congruence in the given systems. So next we can show the uniqueness part. So next we can prove that uniqueness part. So now I can take the two solutions. Let x1 comma x2 be the two solution of the given systems. To prove x1 congruence x2 mod m. Since x1 congruence aj mod mj and x2 congruence aj mod mj. So now subtract this two congruence x1 minus x2. Congruence of aj minus aj is 0 under mod mj. So which implies mj divides x1 minus x2 for every j. For every j. So since M1, M2, etc. Mk are pairwise relatively prime or pairwise relatively prime. So therefore, LCM of M1, M2, etc. Mk is product of all the modulos M. M1 into M2, etc. Mk. So that is M. Therefore, N divides x1 minus x2. So therefore, which implies x1 congruence, x2 mod n. So therefore, uniqueness shown. So hence, the solution is unique. So next, we can see the problems based on the system of linear congruence using Chinese-Remainder theorem. So solve x congruence 1 mod 3, x congruence 2 mod 4, x congruence 3 mod 5 using Chinese linear pair. So this is form of the system of linear congruence. It may be two congruents are given, three congruents are given, or four congruents are given. So this is a standard problem, three congruents with one variable. Okay, using Chinese theorem, we can able to solve this. So by this Chinese theorem, first we can identify the A1 is 1, M1 is 3. And second congruence A2 is 2 and M2 is 4 and A3 is 3, M3 is 5. So now check that the given modulus M1, M2, M3 are pairwise relatively prime. So the M1, M2, M3, M5, 3, 4, 5 all are pairwise relatively prime. So GCD is 1. So now we can able to apply Chinese symmetric theorem. So first find N. So N means M1 into M2 into M3. So 3 into 4 into 5. So that is 6. And next find N1 N by M1. So N is 60 divided by M1 is 3. So that is 20. And the N2 is N by M2. So 60 divided by 4, that is 50. And the N3 is N by N3. So N 60 and N3 is 5. So that is 2. So next, to find Y1, Y2, Y3. So using these conditions, Ni, Yi congruence 1 mod M I equal to 1, 2, 3. So now take I equal to 1. So N1, Y1 congruence 1 mod M1. So N1 already find out N1 is 20, 20 Y1 congruence 1 mod M1 is 3. So now we can choose the Y1 value product with 20. So this left hand side product value, it can be divided by 3, we get the remainder as well. So instead of, we can choose the y1 value, take 1. So y1 equal to 1, 1 into 20, 20. 20 can be divisible by 3. The remainder is 6 3s are 18, remainder is 2. But we are getting remainder is 1. So but don't selecting the 1. So next we can take 2, y1 equal to 2. So y1 equal to 2 means 2 with the product with the 20, 20 into 2, 40. 40 can be divisible by 3. It can be divided by 3. We get the remainder 3, 33 is 39. So we get the remainder is 1. So in this case, y1 equal to 2 is a solution. Y1 equal to 2 is a solution. So this 2 value balancing this first congruence 20 y1 congruence 1. So instead of, we can take the remaining 2 congruence. Instead of, we can solving the remaining 2 congruence for I equal to 2. N2 y2 congruence 1 mod n2. So n2 means 15, y2 congruence 1 mod m2 means 4. So here we can choose the y2 value product to the 15, and this product value, total product value can be divided by 4. We get the remainder is 4. So instead of, we can choose the y2 value by click here. So first we can take 1. So 15 ones are 15. 15 can be divided by 4. So 3 4 so 12. Divided, the remainder is 3. But we are getting the remainder is 1. But don't select it. So next we can take the 2. Y2 equal to 2 means 15 2s are 30. So 30 can be divided by 4. 7 4 so 28. Remainder is 2. Okay, it's not equal to 1. So next we can take 3. 15 3s are 45. 45 can be divided by 4. 11 times, we get the remainder is 1. So therefore, y2 equal to 3. So next we can take I equal to 3. So n3 y3 congruence 1 mod m3. So n3 is 1, y3 congruence 1 mod m3 is 5. So now we can selecting the y3 value by the trial. We can product with the 12, that the total product we can divide by 5, then the remainder is. So now we can choose the y3 value. First we can take 1. Whole ones are 12. It can be divided by 5, then we get the remainder is 2, but not 2. It's not equal to 1. So next we can take 2. So total are 24. 24 can be divided by 4. We are getting remainder is 4. It's not equal to 1 also. And next 3. Whole 3s are 36. So 36 can be divided by 5. We get the remainder is 1. This one. Okay, is correct. So y3 is 3. So this y value is calculated by the trial. So substitute 1, 2, 3, 4 for any values. It will be balancing the system of congruence. Ni, yi congruence 1 unit. Okay, so now I find out y1, y2, y3. So finally, we can substitute. The solution is x congruence a1, n1, y1. There are 3 congruences of the given problems. So we can form the 3 terms. a1, n1, y1, a2, n2, y2, a3, n3, y3. So substitute all the value here. So a1 means a1 is 1 and n1 is 20 and y1 is 2 plus a2 is 2, n2 is 15 and y2 is 3 and a3 is 3, n3 is 12 and y3 is modulo n. N is 60. So 40, 30, 390 plus 972. Mhm. Eight. Yes. No, not it. This one. So adding all this, to 30. So it can be 238 can be divisible by 60. So finally we get the remainder 58 modulo 60. So this is a solution. X congruence 58 modulo 30. So therefore x equal to 58. Okay. So using Chinese dependent theorem, we can able to solving the system of congruence. The system of congruence it may be any number of congruence with only one variable. So in this problem, having three congruence with only one variable x, the problem it may be do this two congruence with one variable, three congruence with one variable, also four congruence also one variable. So the instead of the given problem, we can take this x value, can form the solution this x. Okay. So thank you, students.